guys, welcome to lesson 2.2.1, day 1, transformations of other functions.
So far we've really just been focusing on parabolas, the equations, the graphs, and the transformations of parabolas. But now we're going to kind of spice it up a bit, and we're going to apply everything we learned about transformations to new graphs, new parent functions. Because the same exact rules apply, it's just that the original format of these functions are, of course, different than that of a parabola. So we are learning about 4 new functions today. They are the absolute value function, the rational function, cubic function, and square root function. Now, these pictures are all parent functions of these functions. Just like we had the parent function of a parabola. So these are the OG equations, just like how for the parabola, right, we had y equals x squared. That was our parent function of the parabola, and now we have 4 new ones. So, when we talk about these, we have to use something called a locator point. And what that is the point of the graph that we use to move it left and right or up and down, right? So on each of these functions, there is a special locator point, and we are going to identify all of them. On the absolute value, it is this one right here, 0, 0, that is the vertex. On the parabola, the vertex is the locator point. On the rational function, it's actually where the asymptotes intersect. So here, our locator point is also 0, 0. The locator point for the cubic function is also 0, 0. You'll notice there's a pattern. And same thing here. Okay, so all of these graphs have a locator point at 0, 0, just like our parabola does. Okay, and keep in mind that we always do negative hk. Alright, so that locator point, just like our vertex of the parabola, is also classified by opposite of h, k. So, let's try some practice problems. So if we have this function right over here, the first thing you want to do is identify which parent function it's even talking about. So you'll look at this and be like, this has bars on the outsides. And if we look at our table, this one right here is the one that has bars. So we are obviously talking about the absolute value function. Okay, and then we can start talking about the transformations that take place. So this negative sign tells us that we have a reflection. This 3, I'll just underline it. This 3 is our vertical stretch factor. So we'll say there's a vertical stretch by a factor of 3. And we have an h right here, it's negative 2. And that's going to tell us that we move to the right by 2. And lastly, we have a k of 4, which tells us we have to move up 4. All right, and the absolute value function has a very, very similar look to the parabola as well as the square root function. Really, it's really only the rational function that's super different compared to the parabola. All right, so for this one, speaking of rational functions, we have a rational function. All right, so if we look at our rational function right here, this is the general form. So h is down here at the bottom of the fraction, and k is on the outside as usual, okay, while a is on the top. So we can say that we have a vertical stretch. Okay, this 2 is an indicator of a vertical stretch by a factor of 2. All right, we have an h down here. Our h is a 4, and that tells us, because it's a positive 4, that we're going to move to the left by 4. All right, and lastly, we have a negative 5 right here. That's our k. And this is going to move us down 5. Okay, I guess I didn't really label the other ones. All right. One more example of this. Here we have a square root function. This one was very clearly a square root function because there is a square root in the equation. We have a negative sign up at the front, and we know that that tells us that we have to have a reflection. Oh, let's identify it first. All right, so we have our reflection. We have our h here. It's a negative 6. Oh, I forgot to point out the a first. And we have a k of positive 2. All right, so let's look at what all those do piece by piece. Now, because our a is a 0.5, that's a number that's smaller than 1, right? It's one of those decimals. So that tells us that we actually have a vertical compression this time. Okay, vertical compression by a factor of 0.5, which is just 1/2. H is negative 6. That tells us we're going to move to the right by 6. Remember, H is still always positive, or opposite. Jeez, I can't talk today. All right, and lastly, our K is a positive 2. If it's a positive 2, that means we're moving up 2. Okay, and that is it for those. So the descriptions of the transformations works pretty much just like they did for parabolas. It's just you have to still be able to identify those different pieces, even though the equation looks ever so slightly different. All right, so I've put this here at the top just so we can have something to look at while we're doing these problems. So now we're going to go ahead and go backwards. We are given the description and we have to write the equation. So here we have a cubic function, okay? And keep in mind, a cubic function just means that you have a cube there. It's like, it literally looks just like the quadratic. Instead of a square, it has a cube there. So a cubic function, reflection, left, up, and a compression. So we have a reflection, meaning we need a negative sign. Left 4, which means we have an h value of positive 4 here. Up 3, this tells us we have a k of 3. And here, compressed by a factor of 1/6, that tells us that our a is 1/6. Okay, so now we're ready to write our equation. Just follow the general format. So here we're using this one. So the negative sign comes first, as we know from parabolas. Next up is a. Our a is 1/6, so we'll do a 1/6. And then we have our parenthesis, x. Put the rest of that there. Next comes h. Our h is 4, so we'll do a +4. And lastly, we have a k of positive 3, so we'll do +3. Okay, and that's it. You're done. This is our cubic equation. All right, let's do another one. This time we're working with a rational function, so that tells us we're going to follow this general format. We have a right shift by 8. Because it's a right shift, we have an h, and because it's right, it's going to be negative. Remember, it's always the opposite of what we want. Okay, down by 4, so that's our k. It's down, so it's going to be a negative 4. K, unlike h, isn't opposite. And then a vertical stretch by a factor of 4. This means we have an a value of 4. All right, so following this format, we have y equals, and it's going to be a fraction. A goes on top, so our a is 4, so we put 4 on top. X minus h, so we have an x. And then h, our h is negative 8, so we'll do minus 8. And our k is -4, so we'll do a -4 here, just like this. We just followed this exact format in ours, but substitute our numbers for the letters. Okay, and you're done with that one. All right, one other activity here. This time we are given a graph, and then we have to write the equation. So remember what I said when we were doing that with parabolas. The first thing you want to do is describe the transformations so you know what to do. Now recall that the parent function of each of these is always a good idea to get down first. So like for the cubic graph, actually if we go back to our first page, notice how the cubic function has its locator point at 0, 0, and it's this like funky curve. So I'm just going to sketch that here for us so we can have something to look at. All right, it's not very good, but get the job done. So our original was right over here at 0, 0, and our new one is right here at 2, -1. Okay, so that tells us that we must have moved to the right by 2. I'll write it over here. Okay, and that means h is going to be -2. Remember, h is always the opposite. We moved down by 1 because it lands at -1. All right. This gives us our k. And that is all that happened. We don't have a stretch factor or compression factor. Remember, for these ones, we always assume it's 1 or -1. And notice how this one didn't flip, right? It still starts and ends in the same directions as the original. So we're ready to write our equation. Now, because it's that funky curve, we were able to recognize that it's a cubic function and recall that cubic functions look just like quadratic ones, except instead of a squared, it's a cubed or a little exponent of 3. So we will start. We don't have an a value, or it's just 1, so you can either write 1 or you don't have to write anything. X, and then our h is -2 cubed, and then k is -1, so you just throw a -1 on there. And we're done. It's an ugly line. All right, last one. This, if you want to identify, you got to be good at matching the pictures. So you look at this picture and you're like, which of these pictures does that look the most like? Okay, I'm going to have to go with the square root function here, right? That's the one it looks the closest to. So look at this parent function. Notice how it has its locator point at 0, 0. So I'm going to go ahead and draw our parent function, or just do a little sketch of it so that we have something to go off of. All right, so you look at your original black one, and then you look at your new blue vertex, and you're like, where did it move? Well, it had to move to the right by 1, and it also had to move up by 2. Okay, so we have up 2, that gives us a k of 2, and we had right by 1. This gave us an h of -1, right, because h is always opposite. So if we're right, we're negative. And we also have to notice that it actually flipped. So that's going to give us a negative sign in our equation. So we're ready to write, right? And let's look at the general form real quick here. Our general form looks very similar to the quadratic, except instead of the parentheses and the square, we just have a big square root sign. So we're going to have square root, because remember we don't have an a value, x, and then h comes next, so -1, because our h is -1. Our k is +2, so we'll do a +2 on the outside. Make sure you put that outside of the square root. And recall, we have a reflection, and that gives us a negative sign right in the beginning. Okay, and that's all. Okay, so it's really not much different than what we did for parabolas. It's just a question of being able to recognize the correct parent function and then using the correct general form of that particular parent function. And that's all for today.